This is Signal and System Practice Homework 4.2, Question 2. Using the classical method, solve these equations to get yt if the initial conditions are these two and the input ft is abc. First, so this equation let us to solve yt, which is include two parts. It's natural response plus the forced response. And we can know the polynomial characteristic polynomial form is lambda squared plus 7 lambda and plus 12, which is equals to lambda plus 3 times lambda plus 4. For this polynomial, the characteristic roots are the lambda 1 equals to minus 3 and lambda 2 equals to minus 4. And then we can get the characteristic modes. E2 minus 3t and E2 minus 4t. So we can actually get the natural response, which is y0t equals to the linear sum of these two parts, which is k1 E2 minus 3t plus k2 E2 minus 4t. Which is this part. For the forced response, we need to consider this input ft. So let's deal with the forced response. For the first response, ft equals to ut, which is because we need to use this table. So actually ut, of course, you can also treat it as ut times E2 0t. And for this input, here is the sigma is equals to 0, which is not equal to the lambda 1 or lambda 2. So we can get the forced response equals to beta E2 0t. And then we know the system equation is this equals to d plus 2 ft. Y phi t equals to this part. And there is two methods to solve this forced response. Method 1, we can actually just bring this into this equation and we calculate. It's like d squared y phi t equals to 0 and 7d y phi t equals to 0, and dft is equal to 0, and we only get 12 beta equals to 2, which we can get beta equals to 1/6. For the method 2, we just it's easier. We can just beta equals to we know the transfer function, right? For beta just equal to p sigma over q sigma, and p sigma equals to sigma 2, which is right part and right hand side, and for the q sigma equals to sigma square plus 7 square sigma plus 12, and we know sigma equal to 0, so we just equals to 1/6. This is the second method. After we get this, so we can get the total response equals to K1, which is this part, K1 E2 minus 3t plus K2 E2 minus 4t and plus 1/6. Beta E0t, right? E2 minus 0t. This is natural response. This is forced response. And after we got this, we can use initial condition. First, we need the derivative of yt, so we need to first calculate minus 3 k1 e2 minus t plus minus 4 k2 e2 minus 4t, and we already know the initial condition, which is this 2, so we know 0 and this, so it's y0 is equals to 0. Just equals to 0, and the derivative of yt equals to 1. So this one we can get k1 plus k2 plus 1/6 equals to 0. And for this one, minus 3 k1 minus 4 k2 equals to 1. And then we just calculate these two functions. We can get the final answer, k1 equals to 1/3 and k2 equals to minus 1/2. So the yt equals to 1/3 e2 minus 3t minus 1/2 e2 minus 4t plus 1/6, 1t larger than 0. So this is the final answer. And for the one, the ft equals e2t ut, the similar as the last question. The only difference is The only difference is the sigma here is equals to -1, which is also not equal to lambda 1, lambda 2. So we can get y, the force response equals to beta e to minus t. And basically this is totally the same. So for example, the beta equals to p over sigma over q sigma is like class 1. So we can get still the sigma to, it's totally exactly the same last one. It's just p q minus 1. So in here we can calculate is minus 1, 1, minus 1, 6, 1, is also equals to 1 over 6. So we can get yt equals to the k1, the natural response, e2 minus 3t plus e2 minus 4t, and plus 1 over 6 e2 minus t. And then we also the initial condition. First, let's the derivative of yt is minus 3k1 e2 minus 3t minus 4k2 e2 minus 4t. And this time they have this, so we need a minus 1 over 6 e2 minus t. And then the initial condition, TIAL, initial condition, y0 still same, equals to 0, which is k1 minus k2. This time 1 over 6, and the derivative of y equals to 1, which is equals to minus 3k1 minus 4k2 and minus 1 over 6. So we calculate these two equations. We can get k1 is equal to 1 over 2, k2 equals to minus 2 over 3. So we can get the final solution. The output is yt equals to 1 over 2 e2 minus 3t minus 2 over 3 e2 minus 4t plus 1 over 6 e2 minus t, and t larger or equal to 0. This is the solution of this one. And for third question, exactly same. It's just for this one, since the let's see, ft e2 minus 2t ut, and sigma is equals to minus 2 is not equals to lambda 1 or lambda 2. So the first response y sigma t equals to beta e2 first response e2 minus 2t, which is this part, and then we can use the same to calculate beta, which is p sigma over q sigma, and sigma is sigma minus 2 and sigma plus 2, sorry, this is plus 2 and plus 7 sigma and plus 12, and which this time is minus 2, q minus 2, and we can see it's actually equals to 0. So the eventually yt is the natural response plus forced response, and of course first response equals to 0, so actually it just equals to the natural response, which is k1 e2 minus 3t plus k2 e2 minus 4t. And so this actually is even easier than the before, within the previous two questions. And the same, we derived yt, which is 3 minus 3 k1 e2 minus t minus 4 k2 e2 minus 4t. And initial and TIL. Initial condition. Initial condition is y0 equals to 0, and y derivative of y equals to 1. For 0, we can just equals to k1 plus k2. For this one is minus 3k1 minus 4k2. So we solve these two equations, we can get k1 equals to 1 and k2 equals to minus 1. And so we can get yt just equals to e2 minus 3t minus e2 minus 4t, and t larger or equals to 0. So that's it. This is the solution of this equation. Thank you.